Okay, welcome back everyone to the second part. We are done with chapter number 1.1, where we discussed binary and all those stuff. And now we are moving towards chapter 1.2, which covers multimedia. Now, this part doesn't include any of those binary stuff. This is, as from the term, you guys would be aware of what multimedia is. We are going to be discussing how we store images, how we store videos, and how compression and all those stuff takes place. And also one interesting calculation based question would be how to calculate file size. Like, how do I know that if I take a picture, what would be the size of this specific picture? So the first subtopic under this very chapter of multimedia is bitmap images. Let's get a black pen. Just a minute. Pen totally black. Yes, and we are going to be starting off with bitmap images. So bitmap images basically are all those images which are made up of pixels. What do I mean by the term pixels? We always listen to this term that we have, let's say, 1280 x 720 pixels in this document or in this video or in this image. But what do we mean by pixel? And this is a common 1 or 2 mark question too. Define pixel. So pixel is basically the smallest element which could be represented on a screen. Represented on a screen. And this single pixel usually has some sort of color in it. Let's say if we have a box and like this, a single pixel could, let's say, represent red, and then there could be another pixel which represents the mixture of, let's say, this purple color, and then we have a blue one. And when we define all these pixels and later on check it, an image is being formed which has a lot of colors. Now, pixel is basically the smallest element which could be represented on a screen, and bitmap images are those pixels which are, my bad, are those images which are made up of pixels. Now, how do we store images as pixels? Basically, we need at least 1 byte. 1 byte. Let's get this bit. We need at least 1 byte or 8 bits. 1 byte is basically equal to 8 bits for your info and revision. We need basically 1 byte or 8 bits per pixel to represent a colored image. So what do I mean by 8 bits? Basically, this means that to represent, there could be a question which could ask you, let's say, um, wait, let me explain it in a different context. So a file size basically depends upon several things, including the number of possible colors. So if I make up an image which could have, let's say, 256 colors, that would have a larger file size as compared to file size as compared to an image which only has, let's say, two colors, which are black and white. How do I get to know which one is a larger one and which one is a smaller one in terms of the file size? Basically, we see how much colors are being used in that specific document. Okay, let me start again. Just a minute. Yeah, sure, one. Why not? Okay, yes. So basically, welcome back everyone. And so we were discussing this bitmap images concept. We are done with chapter 1.1, and this is now the chapter number 1.2, or the second section of the computer science chapter number 1, which is multimedia. Multimedia basically refers to how you store images and stuff like that, and how do we calculate file sizes and all those things. So the first thing in this chapter is bitmap images. Now, what do we mean by bitmap images? We always hear this term bitmap images, but a lot of us don't know the exact definition of bitmap images, which could come in exam. Bitmap images basically refer to those images which are made up of pixels. Made up of pixels. And what do we mean by the term pixels? Pixels is basically the smallest element. on a screen which could represent something, some color or some image or something. The exact definition which examiner demand is smallest element which could be represented on a screen. You have to memorize this. This is really important. Memorize this. This comes up as a common 1 to 2 mark question. And what do we mean by pixels? You see, you always hear this term 1280 x 720. Now, when you put this x for a term, this comes up to be a screen resolution. But if you only discuss the 1280 or 720 thingy, that's pixels. And so 1280 x 720 basically means that we have 1280 pixels vertically and 720 pixels horizontally. And this altogether is known as screen resolution. Now, I was basically discussing this concept of how we store data. How do we get to know which one is a larger file size and which one is a smaller file size? For that, we need to understand that the larger, the more colors an image use, the larger would be its file size. If we use 0 bytes, let's say 0 bytes, how do we, okay. Before that, let me clarify. Let me write this formula for you guys, an equation which would simplify everything. Number of colors, number of possible colors is basically 2 raised to power of number of bits. 2 raised to power of bits. This is the easiest equation you guys need to know. Let's say we want to only represent one color, one single color, an entire image, or perhaps the entire screen either only having white color or let's say only having black color. What would be the number of bits? Those would be 2 raised to power 0, because 2 raised to power 0 would give the answer as 1. This means that if we use 0 bits, we could only have one color. Then moving on, let's say 2 raised to power 1. This means 2, and those two are black and white. This means that if we have a document which only has black and white color in it, it is occupying 1 bit. Then moving on, let's make some space up here. If we are discussing 3 colors, and also this is really important, I told you all this in the previous class, that the most 3 common colors are RGB, which refers to red, green, and blue. RGB. And so if we want a colorful image, we need to have at least these 3 colors. And for that, we would go to 2 raised to power 3, which is 8. This means that if an image has 8 bits, it could have possibly 8 colors in one single frame. That could be red, that could be green, that could be blue, that could be indigo, that could be purple, that could be black, white, whatever. But maximum we could represent are only 8 colors. We can't go beyond that. And 8 bits could also be called as 1 byte. So if a question says that we are having an image which is occupying 1 byte space, how many colors could it store? You should get to know that 1 byte basically refers to 8 bits. Oh, my bad, not 8 bits, 3 bits, 3 bits. This is the number of bits, 3 bits. I also got it wrong, my bad, 3 bits. And so 3 bits is approximately around, you could say, that would come with, let me rephrase the question. Let's say if this says something like, there is an image which uses 8 colors. An image which has 8 colors. Tell me what would be the file size in bits. You should get to know that 8 colors. Okay, what would be 2 raised to power 8? 2 raised to power x is 8. You just need to think what would be x. And here I would tell you all a small maths formula perhaps. 2 raised to power x, convert 8 to 2 raised to power something. So 2 raised to power 3 is right. 2 raised to power 3 is 8. And so we see that as the base is same, we get x is equal to 3. And so your number of bits are 3. This is something which is related to maths and it's not related to computer science. But if you could get this concept, it would just make stuff easy for you. Like let's say if we have stuff like 2 raised to power x is equal to 64. Now you won't know what is 64, but how would I get to know 2 raised to power x is equal to 2 raised to power 4 raised to power, let's say 4. 4 raised to power 4 is 4 the 16, 16, 4 raised to power 3 is 64. And then 2 raised to power 2 is 4, right? Multiply by 3. So 2 raised to power x is equal to 2 raised to power 2 into 3 is 6. So you get the answer x is 6. This is something which is related to maths. You guys have covered this in your O-level mathematics or IGCSE maths, and it's not related to computer science, but just for the purpose of clarification, I told you. And now let's say a question says that you have a file which has a file size of 8 bits. How many colors could this represent? The answer to this would be 2 raised to power 8, which would be something 2 raised to power 8 is 120, 100, no, my bad. 2 raised to power 8 would give us 256 different combinations, different combos. 256, and these 256, whatever color it is basically formed by different variation of the common RGB colors. In some color, let's say we have 70% blue, 2% red, and 10%, let's say, green, and that forms a new color, and we could replace it like, let's say, 12% red, 20% green, and 50% blue, and we have a different color. So all these colors which we have in the world, they are formed from the main RGB colors. And this black color basically isn't a color. It's a point where you have no colors at all, or no light at all. A point where there is no light, that color is basically known as black. And white is basically a point where you have a lot of light directly pointing towards one point. That is known as white color. So again, it could be derived from RGB2. If you see any sort of like, I explained it previously, that if you have some Adobe Photoshop something, you would see that even if you go into the red section, you would have this black part at the end. Let's see if we have that up here too. You see more colors. Yeah, I choose this black red one. I have all these shades of red, right? I have the light, and we have this percentage up here too, red lighter 80%. But as I move towards right, this is the plain red, then this is darker, and in the end we again have dark gray, and finally we have this blackish color, which is formed again by the combination of, let's say, red, green, and blue. That's the main concept behind this. This is something which would be a bit confusing, but I hope I clarified it in the right manner. And now let's say we want to represent a very real image, such as these 4K images. How do I get to know how much bits they are? Basically, a very real image usually requires 3 bytes. 3 bytes. Each byte for the 3 RGB red, 1 byte for this, one for this, one for this. And this means 2 raised to power 24, because as mentioned earlier, 1 byte has 8 bits. And so 3 bytes would have 24 bits. And so the possible colors would be 2 raised to power 24, which is a value greater than 1 million. You don't have to memorize all this, but this is for your understanding that if we have at least 3 bytes, that would give this would be like representing a very real image. Now let's discuss some common definitions related to this bitmap images. Let me erase this and then we can start off. Okay, starting off, we discussed bitmap images, which is a system or an image that uses pixel to make up an image. Then we have pixel, which is smallest picture element that makes up an image or could be represented on the screen. The third one is color depth. Color depth. Color depth basically refers to number of, these are definition you guys need to memorize. These are free marks. Number of bits that are used to represent colors, to represent colors in a pixel. Let's say we talk that if we have 8 bits, we could have 2 raised to power 8 equals to 256 colors, right? We discussed this previously up here in this section. And this means that the color depth for this image is basically 8 bits, which is the number of bits that are used to represent each color in a pixel. So a pixel, a simple plain pixel could have 256 different colors. And if we had only, let's say, a single bit, 2 raised to power 1, this means that we could have two possible colors, which would be either black or white. Sorry. And this means that we could only have either black in this color pixel box or a white in here. That's the main concept. The second definition is basically bit depth. Bit depth. And many students basically confuse these two things, including me. Bit depth is number of wait. Okay, my bad. This isn't in this chapter. It's in the next part. I've missed that. Wait. Okay. The next one is image resolution. Image resolution. Image resolution. Image resolution basically refers to number of pixels. Let's erase this and let's write in red. Number of pixels that make up an image. That make up an image. And this is basically like 1000 pixels vertically multiplied by, let's say, 500 pixels horizontally, and that is basically image resolution. Many people know what do we mean by image resolution, but they don't know the exact keywords, number of pixels. Many people try to write from their own self, it's the maximum size of an image which could come up on a screen, and those stuff are wrong. People, the examiners won't award you for that. You need to mention the correct keywords. Those are really, really important. And the last one definition for you guys is screen resolution. Screen resolution. And screen resolution, just like image resolution, is the number of horizontal and vertical pixels that make up a screen display. Vertical pixels that make up a screen display. Now, my laptop basically has the resolution of 1366 multiplied by 768 pixels. By this, I mean that I have 1366 pixels in the vertical direction and then 768 in the horizontal one, or maybe if I'm saying it wrong, but one of these is horizontal and the other one is vertical. And this basically represents full HD. The 4K screens, the devices which have a 4K monitor, those go up to, let's say, 2160 multiplied by something like 1440, maybe, I'm not sure, but it's something like this. At least double the pixel of mine. I have 2K screen resolution or full HD. 2K is basically full HD, and 4K is then the double of mine, which would be something like this. And that represents 4K. We have more pixels. What do we mean by more pixels? More pixels basically mean that we have more bits. And what do we mean by more bits? More bits basically refer to the term that we have more colors to be used in each of those pixels. And due to this reason, a 4K screen has a much realer, what do we call it, a display, because it could represent even more larger shades of a specific color. This is basically the concept of bitmap images. Apart from that, you guys, this is something you guys would be aware of, but let me repeat it for you guys. A lower screen resolution means that the quality would be lower, quality would drop, whereas higher screen resolution would mean that the quality would improve. And how do we improve the screen resolution? Increase the pixels. And how could we increase the pixels? By increasing number of bits, increasing the bits or the bit size. That is all. Under this chapter, we have a small formula which has not been tested, to be honest, but it's there in the book, and I want you all to know this. It's I don't know if it's important or not, but let's cover it up. Pixel density. Pixel density basically refers to number of pixels pixels per square inch. Pixels per square inch. To calculate this, you need to add, firstly, add step number one, add the squares of resolution size. Squares of resolution size. Step number two would be to find its square root. I would do the example, just give me a minute. Find its square root. Square root. Square root is basically this symbol, x under root, this under root or square root. And the third one is divide by screen size. Divide by screen size. Let's say we are told that a screen has a resolution of 1920 multiplied by 1080. According to the first step, we are going to be adding the squares of resolution. What do I mean by adding the squares? We need to add 1920 whole square plus 1080 whole square. We get the answer as 4852,800. Then we need to find the square root according to step number two, under root of this answer, and you get 2202.907. And finally, let's say we have the screen size such as 5.5 inches for a phone. We are going to be dividing this by 5.5, which gives us the answer as 401. And this 401 means that in a single inch of the screen, we have 401 pixels. Now, the reason why we don't have such questions tested till this very moment is that basically examiner don't want to give such confusing, what do we call it, calculations, squaring 1920, adding 1080, taking the square root, and then dividing. That is quite difficult. And the examiner knows this, due to which he doesn't give such confusing stuff. But again, they could ask you of, yeah, calculators aren't allowed. Calculators are not allowed in the exam, and due to that reason, they won't give you such questions at all. But again, if they do, remember, you guys don't have to do this long expansion. I would be doing those questions for you guys. It's not related to this, but we have a similar question which includes multiplication and division and stuff like that. But we could simplify that. Let's say, even if we get it, it would be something like dividing by 1000 or stuff like that, which would get this number to, let's say, 64. Let's imagine we get this answer as 64. So the square under root of 64 would be 16. So we know that under root of 64 is 16. In both the papers, calculator is not allowed. In both the papers, your P2 basically doesn't include calculator at all. You don't have even any question which tests any sort of mathematical question. If you have, it's something like 2 plus 3 or 12 plus 3 is 15, stuff like that. Basic mathematics, basic. Your P1, on the other hand, has some sort of file calculating question, which we would be discussing soon, perhaps maybe in tomorrow's class. And I would tell you all how to go with that, but those are basically pretty simple question, like 1000 multiplied by 8 multiplied by 32 divided by 4. What's the common way to do this? 4 ones are, 4 twos are. 2000 multiplied by 32, it's pretty easy. That would be 2000 multiplied by 32 would be 2032, 64,000, I believe. Let me confirm. 2000 multiplied by 32. Yes, 64,000. So you see, even without the calculator, I got the correct answer, which was pretty simple. So we have shortcuts like this where we could simplify the answer and get to the final answer. And that is all about bitmap images. Now, how do we calculate the bitmap images file size? That would be the last thing today, and then we would be continuing tomorrow. I would have a class tomorrow too, inshallah, and we would cover up vector graphics or and sound files tomorrow. Maybe with that we end the chapter. Okay, we have a small part left, we would do that too. And so now coming up to the important part, calculating the file size. Calculating file size. So how do we calculate the file size? The basic way of doing that is you firstly multiply screen resolution, multiply screen resolution, then You multiply the answer you get with the bit depth. Bit depth basically means number of bits used to represent each color. And then before doing that, you need to understand that in the end, we usually divide by 8. This is the common equation, which is, let me write it up here, screen resolution answer, which would be something like, let's say, 1000 multiplied by 500, let's say. Multiply by your bit depth and then divided by 8. But why do we divide this by 8? This is something many people don't know, and they mostly get it wrong. And that's the purpose of these classes, to highlight such stuff which usually people miss out. The reason behind this is that bit depth is in number of bits. Number of bits divided by 8 basically gives us the answer in bytes. And so this indicates that the main way of calculating the screen size is that we need to convert this into bytes, because 1 kilobyte, 1 KB has 1000 bytes. And then it's quite easy to convert from bytes into bits. Like the answer which we only get from screen resolution multiplied by bit depth would be in bits. To convert it into bytes, we need to divide by 8. And then from bytes to KB, we need to divide by 1000 again, and then so on. So let's solve a small question. And why is this very important? Because sometimes, like, let's create a scenario, and then you would get what I want to say. We have a screen resolution of 500 x 300, okay? And then the number of bits used are 3 bits. Calculate the file size in bytes. We need to multiply this five, not 3. Let's do it as 16. 500 multiplied by 300, okay, multiply by 16 divided by 8. 8 ones are 8 twos are. 500 into 300 is 1,50,000. 5 3s are 15, 2 4. 2, yes, we have 50, and then multiply by 2, we get the answer as 300,000 bytes. And now let's say they say convert this into MB, megabytes. We need to divide this with 1000 first. Clear off the 3 zeros from here. We have 300 KB. And then again dividing this by 1000, you get 2 and 3 divided by 10, 0.3 MB. That's how you calculate a file size. But this MB, we divided it with 1000. In your syllabus, you have it as 1024, which is known as megabytes. We would be discussing this. I believe, why haven't I discussed this till this very moment? Or maybe it's later on. Can they say that? Yes, they can say. But then again, I would tell you how to do that. We have specific shortcuts for that. And those shortcuts are like, let's say if they say, um, we have an answer like 1024 multiplied by 512 and multiply by 8 bits. And then if you want to convert it into megabytes, you divide it by 1024, right? And so you clear this 1024 with this 1024, and then no, we want, yeah, we would be needing a calculator, but again, we have these shortcuts. Okay. And then we have, let's say, some others, like we could simplify it without a calculator, like in this manner. You see, 1024 has been divided by with this 1024. And now 512 multiplied by 8 is something which you guys could do. 8 twos are 16, one up here, 8 ones are 8, 9, 8 fives are 40. So you get the final answer as 4096 KB. Now you need to learn these simplification tips. I would be later on teaching these when we are discussing the megabyte part, but just for your knowledge, this is how you calculate the file size. One other scenario up here, which is really important, is that they sometimes, let's say, give us 500 multiplied by 300 screen resolution, and then they say that 3 bytes are used to represent the colors. Notice I said 3 bytes, not 3 bits. Dividing this by 8 is basically because we want to convert bits into byte. Now, as we already have bytes, we won't be required to, divide by 8. Simply, we need to multiply 500, multiply by 300, multiply by 3, which would give us the answer as, yes, we have to multiply. And that, you see, calculation like this, which is straightforward, that's pretty simple. You see, 5 multiplied by 3 is 15, and then how many zeros you have? 1, 2, 3, 4. Add the 4 zeros. And then multiply by 3. 15 threes are 45. 4, 5, again, just mention the 4 zeros. And you get this answer as in bytes. And now let's say you want to divide it by, okay, in a scenario like this, you would be never asked to divide 4,50,000 with 1,024. No, never. If they ask a question where you have to divide by maybe bytes or convert it into GB bytes, let's say GB bytes is GB, but in that 1024 format and not the 1000 format, then in that context, you would have some sort of simplification method there, which would allow it to further simplify. Let's say 1000, we have 2048, let's say up here 2040. Then you could simplify it like 1, 2, and then 4, like 50,000 multiplied by 2 would be 9 lakh. So you would always have some sort of simplification thing. Otherwise, if they say, remember, if they say give your answer in KB, then you don't have to divide with 1024. You have to just divide it with 1000, and your final answer would be 450 KB. That is how you basically calculate the screen, the file size. This is the formula, the equation: screen resolution multiplied by bit depth divided by 8. Wait, let me write it neatly up here. Resolution multiplied by resolution multiply by bit depth or number of bits used, number of bits divided by 8. If you have this bit depth in bits, and if you have bit depth in bytes, then your equation would be resolution multiply by bit depth, but in bytes. No need to divide by 8. No need to divide by 8. This would directly give you an answer in bytes, which you could later on divide. And why are we doing dividing this by 8 initially? The reason behind this was taught in the first class, and that was that an 8-bit register, usually we have usually an 8 bits register, and one register has the capacity of storing 1 byte. So 8, a register, let's say a single register has 8 bits in it: 1, 2, 3, 4, 5, 6, 7, 8. And this all together, one register occupies 1 byte space. Due to that reason, we have 1 byte equals to 8 bits. Now, if you don't know this concept, you should go watch the first video. It's uploaded there on the YouTube channel. And that's all for today. I hope you guys learned the concept. And if you have any questions, do let me know. If you are watching the YouTube channel, don't forget subscribing to our channel. And if you want to join our group, do comment and I would share the link with you guys.